Greetings everyone, this is Team 19 from Cluster and Cloud Computing, COMP90024, Semester 1, 2021. This is the first part of the demonstration of our assignment 2. Here we look at the overall approach of the project, a layout of the cloud architecture, describe Ansible, CouchDB, MapReduce, and a few other things. Well, the thought of this project comes from the fact that digital expression today is very important. Approximately 3.9 billion people use social media every day, and ever since the early dawn of social media, one question has always been there, which asks, how are you feeling today? And it has been constantly evolving as how humans express themselves over the social medias. Today, we have various ways to express our feelings, emojis, memes, etc. But a substantial part of this literature and digital conversation across all users is plain text. And ever since COVID, the number of people on the internet has grown. So from an academic and social perspective, which covers governments, public welfare organizations, or students like us, it becomes increasingly interesting to understand the well-being of people over the internet and map it with socioeconomic and demographic trends, and further understand them and comprehend them to draw relations between various factors. In essence, in the modern age, we have people constantly expressing themselves online and contributing to the overall feed. So to begin with the project, we were allocated a certain section in the MRC. So step one was setting up the instances using Ansible, which is an open source configuration manager for IT infrastructure. Step two, we started pushing requests to the Twitter API to give us data from the live feed. Step three was to store this data into CouchDB. That was also another instance. And then we also had a replication drive for the main CouchDB. Step 4, which involves analysis, where we try mapping the data from an origin data set to the data that we have collected and try to draw some relations, which we depict in the final step of our entire process is in the dashboard.
We'll start with the Ansible playbooks. We have 3 playbooks here. First is Couch playbook. So here we are only launching the instance. So we have defined all our variables here, and these are the roles, the task which we want to launch. There's some common task. Then we are setting the volume size. Then we are adding some security groups, and then we launch some of the instances. With each instances, the way we launch instances common to every other task, but specifically CouchDB, Harvester, and the front end is deployed with their own particular YAML files. So here we have deployed the variables for CouchDB and the instances, and here we are doing the CouchDB deployments. So this is the YAML file for Couch install, where we are initially adding some dependencies, and then we are just deploying the CouchDB instance. We are changing the ownership and the installation path, and then we are changing the bind address and adding the server admin, and then creating the database. So the Harvester playbook, here we have again launching the instances, and then deploying Docker on the instance that is being launched. Harvester has multiple tasks, so where here we have the analysis part and the harvester part, for which we have written some Docker file for the installations and the running of the program, and then we have a Docker compose for the configuration of the Docker files. And here is the main.yaml file where we uninstall the old Docker, install some dependencies, add Docker and Docker engine. Then we change some of the configuration files for this particular Docker, and then we copy our files. We copy our Docker files and the code files, and then we just run Docker compose with build. So this deploys our Docker, and the same we did for analysis part as well.
5 minutes later.
If you can see this particular has passed all the Docker steps, all the Ansible steps, and if we log into the server now, we can see the Docker is running. So both the Docker are up and running, and analysis part now, and then we can see that it's also harvesting data. So if you can see, this Victoria tweet JSON will keep on increasing because it is harvesting data from Couch, and then it will run the analysis on this particular file along with the other JSON files which contains data from Orin dataset. So the file size is increasing here.
So this is our CouchDB that we have used for this project. CouchDB is very easy to maintain, replicate, and use. The RESTful-like features make it very easy to use. And now I would like to show you two of the views that we have used. Firstly, count by state. As you can see, we are using coordinates, the latitude and longitude, to know which state the tweet is coming from. The states are defined by the coordinate boxes. So finally, if the state is not none, then we are emitting the state and the count for each tweet. The count would be 1 because that is the singular tweet. And the map reduce that we are using will reduce all of these tweet counts per state as the count of the tweets from the states. Now we'll talk about count by hour. When we are sorting the tweets per hour, we are first filtering them by states. So first we are figuring out which state the tweet is coming from and then filtering them by hour. And the same process is repeated. So we are emitting per state per hour how many tweets are being reported. That is all.
So now we are going to look at how we query the map reduce queries and views in the CouchDB. So we are using the same thing in our code as well, where we are using the curl commands to get the data. So for reducing the map query, we need to add database, the document name and the view name here, and we need to put reduce equal to true, and we also need to put group equal to true here. So if we reduce it, it is just going to give the count, but we need to group it via the key as well. And then we have set a limit equal to 10. So if I run it, this is giving me the count of the tweets originating from each state. So the key here is the state, and like Ankita showed, that the state code is set from the lat long bounds here. Similarly, there is another query which we did where we are returning the lat long with the place name and the state code, but we wanted to plot different kind of maps with it. So uh, for each state, we needed to query the map reduce data using the filter. So I have the same thing here, the database, the view name, the document name and the view name. And here I'm also adding a filter using start key and end key. And then I can paginate it with setting a limit and the skip, and the reduce and the group parameters are set to true. So if I run this, this is returning me data for Victoria. Similarly, if I want to say run it for Queensland, I might change the start and end key, and it will return me data for Queensland only. So next we are going to see how we run our front-end application using Docker and NginX. And this is our backend file where we have used different MapReduce queries for different APIs. And as you can see, we are having multiple APIs here, returning all having some different MapReduce queries. In the front end, we have the HTML files and related static files like JS, CSS, data images, etc. So what we are doing here is that we have a Docker installation file. We are installing NginX because we wanted to remove the dependency on the port. So we will read out the backend and the frontend APIs using URL rerouting through NginX. So we are installing NginX on the server. We have some configuration files here. So we have in our configuration files, we have mentioned the readout path here. And then within each backend and frontend, we have our Docker file installing the necessary dependencies and running the necessary commands. Same goes for the frontend file as well, where we have used HTTP server from Node.js package. So we are using the base container from Node, and then we are installing HTTP server using npm. So now in the main.yaml file, after the nginx, we repeat the same step for Docker. We install Docker, we add some dependencies, and then we install Docker, Docker IO, Docker Compose. We have to change these parameters so that the Docker can connect to the internet. So we need to add some proxy settings into this file. So I have mentioned the proxy settings here. And the same goes for the config.json, where we have other proxy settings. So this we are doing this so that the applications inside the Docker container can access the internet via the network bridge. So once we are done with all the Docker proxy changes, we reload the daemon, we restart the Docker, and then here we are adding our files. Some of these steps might appear redundant, that we are checking whether the directory exists or not, but the Ansible script gives an error and stops if the directory already exists and we try to recreate it. But the Docker these commands make sure that it doesn't repeat. Then we are copying our code files there. So we copy the Docker file, we copy the Docker Compose and the code file, and then we change the directory and run the Docker Compose. We did the same thing for front end also, and in the end we restarted the nginx so that the port changes can take place, and then they can read out the data properly. So I'm going to run this. So we have the run script here, front end, where we are running we have the run command, Ansible playbook command. So I'm going to run this from here. So we can see the output being produced here in this file. So like we can see that all the steps in the Ansible has been done and there are no failed steps. So now what we are going to do is we are going to go to this URL and we are going to see that properly. And we can see that this dashboard is loading. There are other dashboards as well, other pages on this website, but we are going to talk about it in our next video, which is more related to the analysis and the UI part.